The thin air at 25,000 feet screamed past the windscreen of Lieutenant Colonel Dutch Ryan's P-51 Mustang as he pressed the throttle forward, pursuing a Messerschmitt 109 that twisted and dove just beyond his gun sight. For 3 years running, American pilots had carved out dominance across European skies through raw determination, and overwhelming numerical advantage. The odds favored them in almost every measurable way. Yet sometimes, the odds weren't enough. Ryan's hit rate, like that of most American fighter pilots, hovered around 30% in actual air-to-air engagements. Military brass considered this respectable. To pilots like Ryan, it felt like failure. He squeezed the trigger and watched his tracers slice through empty sky as the German pilot banked hard, the Luftwaffe man knowing exactly what to do. Stay agile, force the American to guess his trajectory. Exploit that fraction of a second hesitation that came with trying to calculate deflection angles at closing speeds approaching 700 miles per hour. Traditional gunnery demanded something no textbook could reliably teach: intuition, hard-won experience, and a healthy dose of luck. 8 miles below, in a laboratory on Long Island, Major George Miller was installing something that would change everything. Inside a precision-engineered housing sat a mechanical brain, a gyroscopic sighting system that could calculate deflection angles faster than any human nervous system, no matter how sharp. The K-14 gun sight tracked targets automatically, computing lead times for aircraft screaming through the sky at 450 miles per hour. This wasn't guesswork anymore. This was science. This was the future. The evening briefing at the airfield carried the weight of routine, which meant it carried significant weight. Another escort mission deep into German territory, the bombers would be there, lumbering toward their objectives, vulnerable and relying on fighters like Ryan's squadron to keep the interceptors at bay. Fokker-Wulfs and Messerschmitts would come, as they always did, trying to tear through the fortress formations before they reached their targets. Ryan stood before his pilots in the unheated briefing hut, reconnaissance photographs spread across a worn wooden table. Schweinfurt, the rail yards there, the ball-bearing factories they'd already hit twice before. Today would be the third attempt to reduce them to rubble. His finger traced the route on the map, a line that led deep into the German heartland. "We'll rendezvous with the bombers over the channel at 0800, Ryan said quietly. "The moment we cross into German airspace, expect fighters. Stay sharp. Stay together. Watch your ammunition discipline." The squadron commanders studying his face had flown dozens of missions together. They'd watched friends spiral downward, trailing smoke and flame across the industrial landscape of the Reich. They understood the mathematics of aerial combat the way soldiers understand fear, not from textbooks, but from living it. At the speeds they flew, hitting a maneuvering target meant leading your rounds by precise angles, corrections that changed every fraction of a second. Miss by 2 degrees, and your bullets whistled harmlessly behind the enemy's tail. Lead too much, and you fired into nothing but empty German sky. The statistics painted a grim reality. 7 out of every 10 firing passes went nowhere. 7 out of 10 chances to hit an enemy fighter resulted in wasted ammunition and missed opportunities. Worse, those misses often happened exactly when American bombers were taking fire, when every second counted, when the difference between hitting and missing could mean the difference between a crew making it home or vanishing into the countryside. Captain Dick Coker raised his hand from the back of the room. "Sir, what about those new sites they've been testing? Any word on when we might see them in the field?" The question hung in the stale air like cigarette smoke. Everyone had caught rumors about experimental gun sights, computing devices that supposedly took human error completely out of the deflection equation. Most pilots dismissed such talk as engineering fantasy. Impressive on paper, sure, but how would such a delicate instrument possibly survive the chaos of aerial combat? Ryan had seen the preliminary reports. The K-14 gyroscopic gun sight, developed by Sperry Gyroscope Company with technical input from British Ferranti and General Electric, represented something genuinely revolutionary. Instead of relying on pilot intuition to calculate lead angles, the system used mechanical gyroscopes to track a target's movement and automatically compute the proper deflection. The device could theoretically handle target speeds up to 450 miles per hour at ranges between 600 and 2,000 yards. Performance parameters that exceeded anything previously attempted in aerial gunnery. But Ryan also understood the resistance such innovations faced. Colonel Bill Phelan, Chief of Fighter Operations for the European Theatre, had made his skepticism painfully clear during a contentious meeting at 8th Air Force Headquarters the previous month. Pilots win battles, Phelan had declared flatly, not gadgets. He viewed the K-14 as an unnecessary complication that would distract aircrew from proven combat techniques. Phelan represented a significant faction within the military establishment, men who viewed technological solutions with deep suspicion, who preferred to rely on human skill and established tactics. The tension between innovation and tradition had been building for months. While engineers at Sperry worked 18-hour days refining the gyroscopic system, military officials debated whether American pilots even needed such assistance. The Luftwaffe was already showing signs of strain. Fuel shortages were limiting German training programs. Experienced pilots were being shot down faster than they could be replaced. Why risk introducing untested equipment when current methods seemed adequate? Ryan understood both viewpoints. He'd seen the frustration on skilled pilots' faces when they missed clean shots at enemy aircraft. He'd watched bombers fall to fighters that might have been destroyed if American gunnery had been more precise. Yet he also recognized that changing established procedures mid-war carried real dangers. Pilots trained for months mastering deflection shooting with traditional ring and bead sights. Introducing a complex gyroscopic system would require extensive retraining, potentially degrading squadron readiness during the critical months before the anticipated invasion of France. The morning engagement unfolded exactly as Ryan had predicted. The 357th Fighter Group intercepted the bomber stream over Dover, 16 Mustangs sliding into escort formation as the flying fortresses turned southeast toward the continent. German radar detected the formation before it crossed the French coast. Within minutes, yellow-nosed Messerschmitts were climbing from scattered airfields across occupied Europe. What followed illustrated perfectly why American pilots remained frustrated despite their technical advantages. Ryan watched Captain Coker pursue a lone Messerschmitt 109 through a series of tight turns. The German pilot executed textbook evasive maneuvers designed to ruin American firing solutions. Coker fired 3 separate bursts. Each time he led his target by what appeared to be the correct deflection angle. The first burst passed behind the Messerschmitt's tail section. The second group of bullets arced wide right as the German rolled inverted. The third burst might have connected, but the enemy fighter had already vanished into a cloud bank, leaving only the acrid smell of scorched propellant and another missed opportunity. Similar scenes repeated across the sky that morning. American pilots flying superior aircraft with adequate ammunition supplies found themselves unable to convert tactical advantages into decisive results. The 30% hit rate wasn't a measure of courage or lack of skill. It reflected the inherent limitations of human perception and reflexes when attempting to solve complex ballistic problems in 3-dimensional space at closing speeds exceeding 700 miles per hour. Meanwhile, 8,000 miles away in a Long Island laboratory, Major George Miller was conducting final calibration tests on a device that promised to transform these frustrating engagements into precise, predictable encounters. The K-14 gun sight incorporated gyroscopic sensors that continuously tracked a target's angular velocity, feeding this information to a mechanical computer that calculated the exact point in space where bullets and target would intersect. The system eliminated guesswork. It removed human error from the gunnery equation entirely. It theoretically allowed pilots to engage enemy aircraft under conditions that had previously made accurate shooting impossible. But Miller faced his own battles in the laboratories and conference rooms of wartime America. Convincing skeptical military officials to embrace radical technological change required more than successful test results. It demanded overcoming institutional inertia, bureaucratic resistance, and the deeply held belief that American pilots could win the war using traditional methods and superior courage. The fluorescent lights in Building 7 at Sperry Gyroscope Company cast harsh shadows across the workbench where Major George Miller hunched over a maze of precision components. Gyroscopes no larger than a man's fist sat alongside delicate servo motors and tiny gear trains, each piece representing months of intensive development. Miller's hands moved with practiced precision as he adjusted sensitivity settings on the latest K-14 prototype. His engineering mind focused on solving a problem that had frustrated aerial gunners since the first fighter pilots took to the skies. The challenge seemed deceptively simple. When an enemy aircraft maneuvered during combat, a pilot had to predict where that target would be when his bullets arrived, not where it was when he pulled the trigger. At typical engagement speeds, this prediction required calculating deflection angles that changed continuously as both aircraft maneuvered through three-dimensional space. Even the most experienced human pilots relied on intuition and split-second visual estimates to solve these ballistic puzzles. The 30% hit rate reflected the inherent limitations of this approach. Miller's solution bypassed human perception entirely. The K-14 used a gyroscopically stabilized optical system that tracked a target's angular movement in real time. As the pilot kept his target centered in the sight's reticle, mechanical computers built into the device calculated the target's rate of angular movement. The system combined this data with range estimates and known ballistic characteristics of the aircraft's guns, then projected the proper aiming point directly onto the pilot's field of view. Guesswork vanished. Gunnery transformed from art into precise science. But translating this concept into functional hardware presented formidable engineering challenges. The gyroscopes required to stabilize the sight had to operate flawlessly under extreme conditions. Subjected to gravitational forces exceeding 6 times normal Earth gravity, temperature variations from -40 degrees Fahrenheit at high altitude to over 100 degrees in desert climates, and constant vibration from aircraft engines and machine gun recoil. Traditional gyroscopes used in naval or ground-based applications simply couldn't survive such punishment. Miller had spent the previous 8 months redesigning every component. Gyroscope housings were machined from aircraft-grade aluminum. Internal mechanisms were precision-balanced to tolerances measured in thousandths of an inch. Servo motors that adjusted the sight's aiming reticle incorporated shock-absorbing mounts to isolate them from aircraft vibration. Even electrical connections used specialized combat-rated cables that could withstand the physical stresses of high-speed maneuvering. The breakthrough came in February. Miller's team had mounted a prototype K-14 in an especially modified P-51 Mustang and subjected it to a punishing series of aerobatic maneuvers designed to simulate combat conditions. Previous prototypes had failed spectacularly. Gyroscopes tumbled out of alignment, servo motors seized due to excessive gravitational loads. Optical elements shattered from vibration stress. But the February test unit had emerged from 20 minutes of violent maneuvering with its calibration intact and all systems functioning normally. The implications were staggering. Ground tests using film footage of maneuvering targets showed that pilots using the K-14 could achieve hit rates exceeding 70% under conditions where traditional sights yielded success rates below 20%. Everything changed if this device could deliver those results in actual combat. The gyroscopic sight performed with remarkable effectiveness at extended distances, precisely where conventional manual aiming became nearly impossible. Targets hovering between 1,500 and 2,000 yards, ranges that pilots had previously dismissed as hopeless, suddenly transformed into legitimate engagement opportunities. Yet Miller discovered that the real battle had nothing to do with mechanical performance. Colonel Phelan stood at the center of institutional resistance, but his objections ran deeper than technical concerns. A generation of senior Air Force officers had built their careers around a fundamental belief. Pilot skill and aircraft capability alone determined aerial combat. The idea that a mechanical contraption could enhance or even supplement human judgment struck them as an affront to everything they'd constructed their military philosophy upon. The resistance took practical form. Procurement specialists questioned whether the sight's intricate design might actually degrade aircraft reliability. Training commanders worried that pilots would grow dependent on the apparatus, abandoning the raw gunnery instincts that had carried them through previous campaigns. Supply officers calculated the staggering logistical challenge of maintaining countless precision instruments across forward airbases where spare parts and experienced technicians were perpetually in short supply. Miller grasped these objections intellectually, but he recognized they obscured the essential truth. American factories were churning out fighter aircraft at stupendous rates. Yet all that production meant nothing if pilots couldn't transform lead into confirmed kills. Every round that missed represented wasted ammunition, squandered seconds, and potentially American bomber crews who would never see home again. The K-14 offered something different, a force multiplier that could dramatically boost existing aircraft performance without requiring new production facilities or major design modifications. Critically, the concept hadn't emerged from American laboratories alone. British engineers working at Ferranti Limited had already demonstrated what mechanical gunnery solutions could accomplish. Royal Air Force pilots flying Spitfires and Hurricanes had operated under different tactical conditions. Yet their Mark II gyro sight had proven that the basic principle worked. Miller's American design built upon those British foundations while dramatically advancing them. Where the British system remained relatively crude, the K-14 offered superior range capabilities and target tracking precision that matched American tactical requirements. The Mustang's extended engagement ranges, often exceeding 1,000 yards, demanded different technology than what worked in the tighter European air combats. At high altitude, where bomber escort missions typically occurred, aircraft encountered severe turbulence that made stable aiming virtually impossible using conventional methods. The K-14's gyroscopic stabilization countered those effects through mechanical sophistication. Perhaps most importantly, Miller had engineered the device for American mass production using materials and techniques already established in domestic factories. Yet that very advantage created complications. The nation's gyroscopic manufacturing facilities operated at maximum capacity, producing instruments for naval applications, aircraft navigation systems, and anti-aircraft defense networks. Dedicating production lines to the K-14 meant stripping resources from other military requirements. Miller's estimates suggested 6 months minimum from military approval to meaningful production quantities. 6 months while American and German pilots were already engaged in their deadly mathematics over European skies. The pressure intensified with each incoming combat report. German pilots, despite deteriorating fuel supplies and inadequate training pipelines, continued extracting devastating tolls from American bomber formations. Their heavy cannons could reduce a flying fortress to flaming wreckage with mere seconds of accurate fire, making every missed shot by American escort fighters potentially catastrophic. The casualty calculations were merciless. American bombers were being lost at roughly 4% over German territory, rates that couldn't continue indefinitely without destroying the strategic bombing campaign that military leadership considered absolutely essential for European victory. Miller recognized that his gyroscopic sight represented far more than incremental improvement. It embodied something fundamental, a complete reconception of aerial warfare, where systematic mechanical enhancement could replicate across entire squadrons what previously depended upon individual pilot brilliance. The question haunting him was whether bureaucratic obstacles and institutional inertia would prevent this transformation from happening while it mattered for the war's outcome. The telegram reached Liston Airfield on a morning in late April, shrouded in grey English weather. Its arrival shattered months of routine that had governed the 357th Fighter Group. Lieutenant Colonel Dutch Ryan examined the message twice before summoning his squadron commanders to the briefing room. The Army Air Force's Technical Command was requesting pilots willing to test an advanced gyroscopic gun sight, equipment that could potentially revolutionize how American pilots engaged enemy fighters. Ryan observed the reactions carefully. These were men who'd endured the Luftwaffe's fiercest attacks, watched comrades vanish into German ground fire, nursed crippled aircraft across hundreds of miles of hostile terrain. They possessed the hardened skepticism of combat veterans who'd witnessed too many breakthrough technologies collapse spectacularly when reality intervened. Captain Dick Coker's voiced the collective concern first. "Sir, with respect, we've been promised miracle weapons before. Most of them work terribly when they matter most." The underlying anxiety was genuine. The Allies were preparing their cross-channel invasion, an operation demanding absolute air superiority above the landing beaches. Fighter squadrons couldn't risk compromising performance by experimenting with untested equipment during history's most critical military operation. Every pilot, every aircraft, every sortie contributed directly to that larger objective. Yet Ryan recognized the current approach was failing. The previous week's Berlin mission had crystallized the problem. His pilots had encountered Focke-Wulf 190s attacking a B-17 formation near Brandenburg. Despite achieving advantageous positions and expending considerable ammunition, the Americans had destroyed only 2 German fighters while losing 3 bombers to concentrated cannon fire in less than 10 minutes. The technical specifications attached to the telegram were compelling. Test pilots using the K-14 had achieved hit rates exceeding 60% compared to the 30% average from conventional ring and bead sights. More dramatically, the gyroscopic system remained effective at the extended ranges where traditional methods became essentially useless. The implication was revolutionary. American fighter tactics had evolved entirely around the limitations of existing gunsight technology. Pilots received training emphasizing closure to 400 yards or less before firing, accepting increased vulnerability to enemy defensive fire for marginally improved accuracy. The K-14 promised engagement ranges beyond 1,000 yards, allowing American fighters to destroy German aircraft while remaining safely outside their defensive weapon envelope. Participating in the testing program meant assuming immediate risks against hypothetical future advantages. Installing experimental equipment violated standardization protocols designed to ensure reliability across all operational squadrons. If the gyroscopic components failed during combat, pilots might find themselves unable to function as effective weapons, compromising not merely their own survival, but the safety of bomber formations they protected. Miller's team at Sperry had anticipated such concerns. The K-14 incorporated mechanical backup systems, allowing pilots to switch to conventional aiming if the gyroscopic apparatus malfunctioned. The optical components functioned as traditional ring and bead systems when the gyroscopic elements were disengaged. Equipment failure wouldn't render pilots helpless. Additionally, rapid removal and replacement capability meant maintenance personnel could swap defective units without extended aircraft downtime. Ryan's personal P-51 Mustang received the first K-14 installation. Sperry technicians labored through the night, mounting the apparatus and executing calibration procedures that extended into dawn. The device appeared deceptively straightforward to the pilot, a standard gun sight with additional controls for range estimation and tracking sensitivity. Internally, Miller's engineers had concentrated staggering complexity into the compact housing. Precision gyroscopes, mechanical computers, and optical systems representing 1944's technological frontier. The initial test flight paired Ryan against Captain Coker in aggressive mock combat. When Ryan maintained his target within the site's tracking envelope, the K-14 performed precisely as advertised, automatically calculating deflection and presenting accurate aiming solutions. The device struggled, however, during high-speed rolling maneuvers that made targets move erratically across the field of view. These early findings prompted tactical adjustments. Rather than employing the turning engagements characteristic of previous air combat, K-14 equipped pilots learned exploiting speed advantages to dictate engagement geometry that suited the gyroscopic system's capabilities. The Mustang's performance characteristics, particularly its exceptional speed and climb rate, proved ideal for such an approach, allowing pilots to control combat conditions and maintain the stable tracking the apparatus required. Subsequent test flights showed increasingly impressive results. Ryan discovered that the K-14 excelled precisely where conventional gunnery failed most catastrophically. Long-range shots against enemies flying straight, previously considered ammunition waste, became high-probability kills. Deflection shots against turning targets, virtually impossible with traditional sights, yielded consistent hits under gyroscopic guidance. The psychological transformation mattered equally with the technical achievements. Pilots wielding the K-14 reported dramatically increased confidence. Understanding their equipment was solving gunnery problems that previously relied upon intuition and fortune. This confidence manifested as more aggressive tactics and willingness to engage under circumstances that would have deterred pilots carrying conventional sights. Nevertheless, institutional opposition within the Army Air Forces remained formidable. Colonel Phelan had accumulated support from other senior officers, questioning whether advantages justified the complexities and costs of widespread implementation. Production requirements would consume 6 months and divert manufacturing capacity from other critical military programs. Training schedules would remove experienced pilots from combat operations for weeks, precisely when the invasion preparations demanded every available fighter. Miller understood that technical success in controlled testing wouldn't guarantee military adoption. The K-14's fate depended on demonstrating conclusive advantages under genuine combat conditions, proving the apparatus enhanced American fighter effectiveness while maintaining the reliability combat operations demanded. The window was closing rapidly as Allied commanders finalized invasion timelines, and military procurement officials faced increasing pressure against any changes threatening operational readiness. The implications extended beyond a single weapon system. The K-14 symbolized a broader transformation in military technology, the shift towards sophisticated electronic and mechanical systems that would characterize post-war warfare. Whether America embraced or rejected this transformation would affect not only the European campaign's immediate outcome, but the trajectory of military aviation development for decades ahead. The personal cost became apparent on May the 7th when Lieutenant Jimmy Watanabe failed returning from Munich. Miller received the combat report that evening while reviewing production schedules at his Long Island office. The typed pages described how Watanabe's Mustang had been jumped by 2 Messerschmitt 109s while escorting bombers to a BMW aircraft engine factory. The 22-year-old California pilot had positioned himself perfectly for clear shots at both German fighters, but missed with every burst, his rounds passing through empty sky as the enemy aircraft twisted from his line of fire. The Messerschmitts had responded viciously. Their cannon shells tore through Watanabe's wings and engine cowling before his aircraft entered an uncontrolled spin toward German farmland. Miller stared at the pages until the words dissolved together. Watanabe had been among the 357th's most naturally gifted pilots, an exceptional marksman whose training scores had been remarkable, yet struggling against the deflection shooting that defined aerial combat. His death transcended statistical casualty counts. It crystallized the human consequence of America's failure, translating technological capability into battlefield results. The K-14 gyroscopic sight remained locked away in the Sperry's production facility, its effectiveness proven beyond doubt in rigorous testing, yet trapped by the slow machinery of military bureaucracy. Meanwhile, pilots continued dying in the skies over Europe, their lives claimed by gunnery problems that this single invention could have solved. The human cost weighed heavily on Miller's engineering team. These dedicated men were pushing themselves through exhausting 16-hour workdays, perfecting every mechanical detail of systems designed to bring their comrades home alive. But their accomplishments stayed bottlenecked in endless procurement channels and testing protocols, while combat reports kept arriving with the same heartbreaking patterns repeating week after week. Young American pilots, fresh from training programs and barely prepared for what awaited them, faced battle-hardened Luftwaffe veterans who possessed superior tactics and firepower. The technological edge that the K-14 represented could shift everything in America's favor. Yet it sat idle while more pilots like Watanabe made the ultimate sacrifice because their equipment simply wasn't good enough. When Miller received the latest assessment of the K-14 program from senior officials, his frustration intensified. The document being circulated among the highest levels of the Army Air Forces characterized the gyroscopic sight as an unnecessary complication that would distract pilots from mastering fundamental gunnery skills. The argument maintained that American fighter pilots were already achieving respectable results through conventional methods, and that introducing complex mechanical systems would overwhelm maintenance personnel deployed far from home, personnel who simply didn't have the resources to support such sophisticated equipment. The colonel's opposition reflected a much larger resistance that permeated military aviation leadership. Many senior officers had built their careers during an era when individual pilot ability determined the outcome of air battles, and they viewed technological innovations with profound suspicion that bordered on outright hostility. These commanders believed that courage, rigorous training, and better aircraft design gave adequate advantages over enemy forces, making advanced fire control systems unnecessary complications that might actually hurt combat effectiveness rather than help it. Yet Miller possessed knowledge that contradicted these assumptions entirely. His contacts within technical intelligence circles provided access to captured German aircraft and weapon systems that revealed just how far ahead the Luftwaffe had advanced technologically. German engineers were working on air-to-air rockets, upgraded cannon systems, and revolutionary fighter designs that threatened to overwhelm America's numerical superiority through superior firepower and performance characteristics. The kind of war that some leaders remembered, where individual pilot skill and aircraft quality determined everything, was rapidly transforming into a technological competition where whichever side could deploy the most advanced systems fastest would win decisively. The urgency became crystal clear when Miller reviewed combat footage from recent battles over Germany. Luftwaffe pilots had developed new tactics specifically designed to exploit the weaknesses in American gunnery systems. Rather than fighting traditional dogfights, where superior American training usually prevailed, German fighters were launching high-speed strikes from unexpected angles that minimized their own exposure while making it incredibly difficult for American pilots to calculate deflection shots accurately. These tactics devastated pilots relying on conventional ring and bead sights, but the K-14's automatic tracking would have neutralized most of this advantage. Miller chose to bypass the official procurement system entirely by arranging direct demonstrations with operational field commanders who had the authority to approve combat trials. He reached out to Brigadier General Frank Hunter, who commanded fighter units for the 8th Air Force, requesting permission to equip a small number of aircraft with K-14 sights for operational testing. Hunter possessed a more practical mindset regarding military innovation than many subordinate officers, and he showed genuine interest in technological solutions, especially ones that promised to reduce American casualties and improve mission results. Their meeting took place in Hunter's office at High Wycombe, surrounded by wall maps depicting how far American bombing operations were now penetrating into German territory. Miller walked Hunter through combat reports documenting exactly where conventional gunnery fell short while explaining how gyroscopic sights could fill those gaps. Hunter listened intently, asking pointed technical questions that demonstrated he truly understood the operational ramifications. The general's main worry centered on dependability. Would the K-14 continue working effectively during actual combat, or would it fail when pilots needed it most and leave them vulnerable? Miller drew upon months of intensive testing conducted at facilities in Spares. The gyroscopic sight had endured temperature extremes, vibration levels, and gravitational forces that far exceeded anything pilots would encounter in real operations. Component failure rates stayed well below military acceptable limits, and backup systems meant pilots could still use conventional gunnery methods if the gyroscopic components stopped working. Beyond that, combat evaluation flights conducted by experienced test pilots had shown steady improvements in shot accuracy without affecting aircraft performance or pilot workload. Hunter's decision to authorize limited field trials became a breakthrough moment for the K-14 program. The general's backing provided crucial political cover to overcome opposition from officers below him while setting a foundation for wider deployment if the initial trials succeeded. Hunter decided the trials would equip 12 aircraft from the 357th Fighter Group with gyroscopic sights, allowing them to be tested under genuine combat conditions while keeping enough conventional aircraft in the squadron to maintain operational capability. Installing these systems required extraordinary coordination between Spares technical specialists and Air Force maintenance crews. Each K-14 site needed precise calibration matched to its specific aircraft, accounting for gun harmonization, ammunition weight distribution, and how that particular aircraft handled in flight. The gyroscopic systems demanded specialized maintenance procedures that frontline mechanics needed to learn quickly, adding strain to logistics operations already operating at maximum capacity. Miller oversaw the first installations personally, working directly with Air Force technicians to ensure the gyroscopic sights integrated properly with existing aircraft systems. The installation process surfaced numerous compatibility issues requiring improvised fixes. Electrical connections interfering with radio systems, mechanical mounts conflicting with existing instruments, optical alignments shifting under high-stress maneuvering. Each problem demanded urgent solutions to stay on schedule with Hunter's approved timeline. The human weight of this technological transformation occupied Miller's thoughts constantly as he watched pilots train on K-14 operation. These young men, most still in their early 20s, carried the burden of proving whether American engineering could deliver real advantages against enemy forces. Their success or failure would shape not only the K-14 program's future, but potentially influence crucial air battles approaching rapidly as Allied invasion plans neared execution. Miller recognized that these next few weeks would reveal whether months of engineering work would produce real battlefield results or become just another promising idea that never changed the war's outcome. The K-14 received its first combat test on June 2nd, when Lieutenant Colonel Dutch Ryan led 12 Mustangs equipped with gyroscopic sights toward flying fortresses under German attack near Magdeburg. German radar operators had spotted the bomber stream while it was still crossing the North Sea, giving Luftwaffe controllers time to assemble interceptor squadrons across the expected flight path. By the time Ryan's fighters arrived, 30 Messerschmitt 109s and Focke-Wulf 190As were already tangled in aerial combat with the bomber escort across 50 miles of German airspace. Ryan spotted his first target at 1,800 yards, a lone Messerschmitt diving toward a damaged B-17 that had fallen behind the main formation. Normally, a shot from that distance would have seemed wasteful. Conventional ring and bead sights became nearly useless beyond 800 yards, especially against moving targets. Yet the K-14's gyroscopic tracking maintained a perfect solution as the German fighter executed its shallow diving turn. The yellow nose spinner grew larger through Ryan's sight picture. The engagement lasted less than 10 seconds. Ryan centered the Messerschmitt in his sights, and the K-14's mechanical computer processed the target's angular movement, combined that data with range estimates and ballistic coefficients for the Mustang's 50-caliber machine guns, then projected the correct aiming point directly into Ryan's field of view. When he squeezed the firing button, 6 streams of armor-piercing and incendiary rounds converged precisely where the gyroscopic sight predicted the German fighter would be. The results shattered every expectation from the testing program. Ryan's bullets struck the Messerschmitt's engine cowling and wing root, rupturing fuel lines and destroying critical flight controls. The German aircraft flipped inverted and plummeted downward, trailing black smoke and fragments of aluminum. The pilot never got a chance to fire back or execute evasive maneuvers. The engagement finished before he even knew he was under attack. Captain Dick Coker, flying on Ryan's right wing, watched the entire sequence unfold and immediately grasped what it meant. The K-14 had enabled Ryan to destroy an enemy fighter under circumstances that would have made conventional gunnery impossible. The range, deflection angle, and target speed had combined to create a firing solution that human pilots couldn't calculate fast enough to execute successfully. The gyroscopic sight had solved it automatically, requiring only that Ryan keep visual contact with his target long enough for the mechanical computer to generate an accurate solution. Similar engagements unfolded throughout the morning as other squadron pilots discovered what the K-14 could do. Lieutenant Bob Harrison intercepted a Focke-Wulf 190 attempting to attack bombers from above, engaging the German fighter at 1,300 yards, while both aircraft climbed and turned. The gyroscopic sight tracked the target through a complete barrel roll, maintaining firing solutions that allowed Harrison to score hits with 3 separate bursts. The German pilot, apparently hit by the first attack, tried to escape by diving toward cloud cover, but never reached it. By midday, the 12 Mustangs with K-14 sights had destroyed 8 German fighters without losing a single aircraft. More importantly, they had won these victories while engaging targets at ranges and under conditions where success would have been nearly impossible using conventional gunnery methods. The gyroscopic sights had effectively extended the engagement envelope for American fighters, letting them destroy enemy aircraft while staying outside the effective range of German defensive fire. The tactical implications became obvious during mission debriefing at Leiston Airfield. Ryan's pilots explained how the K-14 had fundamentally changed their approach to aerial combat. Rather than maneuvering to achieve close-range firing positions, a process that exposed them to enemy fire and wasted precious time while bombers remained under attack. They could fire immediately upon seeing targets, often destroying German fighters before the enemy pilots even realized they were under attack. Captain Coker captured the transformation with words earned through years of combat experience. "Sir, it's like having a crystal ball that shows you exactly where to aim." The German pilots haven't figured out how to counter it yet because they don't know it exists. They're still flying tactics designed to defeat pilots using ring and bead sights, but we're not playing by those rules anymore. The success sparked immediate enthusiasm from other fighter groups operating across the European theater. News of the K-14's effectiveness rippled through the informal networks connecting American airfields throughout England, passed along by pilots, ground crews, and intelligence personnel who recognized the importance of what they had witnessed. Within days, Ryan was handling requests from squadron commanders eager to learn when their units might get the same equipment. The excitement at operational levels stood in sharp contrast to continuing resistance from Army Air Force's leadership. Colonel Filing's response to the combat reports showed his deep skepticism about technological solutions to tactical problems. He contended that results from a single engagement couldn't justify the enormous procurement and training efforts that widespread K-14's deployment would demand. More troubling, Filing suggested that gyroscopic sights might actually damage long-term pilot effectiveness by fostering dependence on mechanical systems that could fail at crucial moments. The disagreement escalated when maintenance records revealed initial technical issues with K-14 installations. 2 gyroscopic sights experienced calibration drift during intense maneuvering, needing recalibration before operation. Another unit failed when temperature extremes during high-altitude flight damaged components. Though these problems were relatively manageable and fixable through improved manufacturing, they gave ammunition to critics arguing the devices were too complicated for reliable field use. Miller found himself squeezed between operational commanders demanding immediate K-14 expansion and procurement people insisting on much more testing before authorizing production increases. The engineering obstacles were solvable, and spares manufacturing could support monthly production of several hundred units once dedicated assembly lines were running. But bureaucratic resistance seemed nearly impossible to overcome, particularly given the tight timeline imposed by Allied invasion planning. Intelligence reports complicated matters further by indicating German engineers were developing countermeasures specifically designed to neutralize gyroscopic gun sights. Captured documents showed that Luftwaffe leadership knew about British experiments with similar systems, suggesting that Ryan Squadron's tactical advantages might be temporary. German pilots were already testing new evasive maneuvers intended to disrupt the stable tracking conditions that gyroscopic sights required for accurate firing solutions. The race between American deployment and German countermeasures created pressure on procurement decisions that were already complicated by politics and technical factors. Miller knew the window for gaining decisive advantages with the K-14 was closing rapidly. Once German pilots adapted to counter gyroscopic sights, the American advantage would shrink substantially. The central question was whether institutional resistance could break down fast enough to achieve meaningful deployment before enemy countermeasures rendered the system less effective. The implications extended far beyond immediate tactical concerns. The K-14 program's ultimate fate would influence how American military aviation developed after the war, determining whether the services would adopt sophisticated fire control systems or stick with pilot skill and conventional weapons. This decision would reshape aerial warfare for decades beyond the current conflict.